Hello, my name is Bruce Whitfield, and this is Homework 6 for ECN 423, Section 1. This is Question 2, creating an ALU controlled with a finite state machine with feedback. You were supposed to create the ALU program, program for the finite state machine, make those into components in a top level system, and then create a test bench to test the actual top level system. Right here I have the ALU, which is very similar to the ALU in the first question. I've set up the entity with two 4-bit inputs, a 2-bit selector, and a 4-bit output. The architecture setup with a 4-bit temp signal to hold the output value. And then you have a process with a sensitivity list of the two 4-bit inputs and the 2-bit selector. And then a case statement with the 2-bit selector. When the 2-bit selector is 0, 0, it performs the first operation, which is an OR operation. When it's 0, 1, it performs an AND operation. When it's 1, 0, an addition, and 1, 1, a subtraction operation. And at the very end right here, I have the output equal to the temp in order to store the signal's value into the output's value. Next, I will show the finite state machine with feedback. Alright, so I have created an entity which is very similar to the finite state machine without feedback. It's got the 3 inputs, which are clock, the data in, and reset, and then a 2-bit output for data out. And then an architecture with 3 signals. One is the current state, next state, and a temp signal that I actually ended up not using, and I do need to take that out. I have created a process statement with clock and reset in the sensitivity list. If clock is 1, then the current state is set to 0, 0, and in the case of a clock event and clock being enabled at 1, then the current state is equal to the next state. I ended the process there because this is a finite state machine with feedback, so I created another process with a sensitivity list of the selector and the data in. I have a case statement. When the selector is 0, 0, data out is 0, 0 as well. But if the data in is 1, then the data out will be 0, 1, and the next state will be 0, 1. If the data in is 0, it will remain at state 0, and so the next state will be state 0, and data out will be 0, 0. I ended the if there, and when the selector is 0, 1, if data in is 1, then the data out will become 1, 0, and the next state will be 1, 0, i.e. the second state. If data in is 0, it will remain at state 1 with data out being 0, 1, and the next state being 0, 1. My next if statement, my next when statement is when the selector is 1, 0, if the data in is 1, then the data out will become 1, 1, and the next state will be 1, 1, which will be state 3. If data in is 0, then then data out will remain 1, 0, and the next state will remain at 1, 0. Now, when the selector is 1, 1, and data in is 1, data out will become 0, 0, and next state will be 0, 0, i.e. it restarts the sequence at the very beginning to the first operation of the ALU. If the data in is 0, the data out will be 1, 1, and the next state will be 1, 1, i.e. it is staying at state 3. And next I will show my top level. Okay, now my top level, I have set up a entity with the ports being two 4-bit inputs, a 2-bit selector, a 4-bit output, 3 1-bit inputs, and 1 2-bit output. I have in my architecture created a component for the ALU with the ports from the ALU that I've just shown. And then I created a component for the finite state machine with feedback with the ports that I've shown for the finite state machine previously. And these two portions right here is me creating the ALU component and the finite state machine with feedback component. And then right here is instantiating my ALU and instantiating my finite state machine, which ends my the top level. Next is the test bench for the top level. As you can see, I've created the entity for the test bench. The architecture is set up with signals that represent the inputs and outputs of the top level system. And right here is creating the component for the top level system. And this is instantiating the component for the top level system. Down here for the test bench, I have it set up where it's, the clock, it responds to the rising edge. So I have clock 0, clock 1. Reset is set to 1 in both of them. And my goal is to just, reset the program so it starts off with, at a restarted point. And then I have, going to the rising edge when D is 1, it will go, while it's in state 1, it will go to state 1. And then when the next rising edge, when DN is 1, it will go to state 2. And at the next rising edge, when D is 1, it will go to state 3. And at the last rising edge, when D is 1, it will go back to state 0. And so I set up my test bench like that just to cycle through the actual sequence and the operations. Next, I'm going to show my test bench. So starting off right here, the one thing is, since this is a finite state machine that has feedback, right here for apologize. Right here, the A, B, S, and O all represent the ALU. Now, the ALU, it goes from state 0, 1, to 2, to 3, and back to 0. And reset in the beginning is set to 1, and when it is set to 1, the selector bit is set to 0 through that portion. And at the next rising edge, whenever DN is 1, it changes to state 2. And at the next rising edge, when D is 1, it will go to state state 1, rising edge, state 0, rising edge, state 1, rising edge for D, and it goes to state 2, rising edge for D, so D is 1, it goes to state 3, and the next time that D is 1 and clock is 1, it goes to state 0. Now, this is a finite state machine with feedback. So initially looking at this, looking at the D out, which clock, reset, D in, and D out are part of the finite state machine. Now the finite state machine runs off feedback. So initially the ALU is holding this value for state 0, 0. When it goes into the finite state machine takes in that, and because it goes off of the current state to figure out the next state, that is why on the output for the finite state machine it starts at 1, and then whenever the next time that the next rising edge, when D is 1, it goes to state 3. So state 1 it started off at for the output for the finite state machine because that it has feedback. So started at 0 that it got from the ALU, it goes into the finite state machine, and at the rising edge it goes to state 1, and then at the next state 1 state 2, I guess, and then at the next rising edge it will go, the output for the finite state machine will go to state 3, and at the next rising edge, and also when D is 1, it will go to state 4, and at the next rising edge it will go to state 0 again for the finite state machine's output, and then it cycles back again to state 1 at the next rising edge. So, just to be clear, my values for A and B, the two 4-bit inputs, A is 1, 1, 1, and B is 0, 0, 0. I have the clock transitioning from 0 to 1, and at every rising edge, the output for the finite state machine and the output for the ALU change to a different state. Now, like I had said, the reason why the output for the finite state machine starts at state 2 is because that value put into the finite state machine from the ALU, it starts at state 0. So the only progression is to state 1. And as you see, once it does cycle to state 4, it goes back to state 1 and then state 2. So this is my waveform for homework 6, question 2. Thank you very much.